So welcome everybody to our FTC workshop.
Ooh, sorry, I'm slacking.
Brought to you by the Nerds of the North. So this FTC workshop, we will go over 3D modeling, and some of the topics we're going to cover are getting started with Fusion 360, creating part libraries, joining components, 3D printing, and some showcases of other teams, and some resources you can check. And you should also note that this is like an overview of 3D modeling. We can't go too much in depth, but we can start with an overview of how we can use the Fusion 360 to 3D model our robots. We expect you to mute your microphones, and if you have any questions, then you can put them in the chat, and I can bring you to our panelists.
Yeah, so hi everyone. This one's gonna work a little differently than our previous ones in that we're not gonna have panelists as much as just me babbling on for an hour. But yeah, so just a little bit about myself. I've been using 3D modeling tools for about 6 years now. I've been really heavily invested in Fusion 360, but have experience with a variety of them. And then I do a lot of 3D printing and laser cutting and kind of all the resources that rely on 3D modeling and some of the benefits you gain from that. Oh, and I'm also team captain of FTC 3208 and president of the statewide FRC team. So just kind of an overview for those who don't know what 3D modeling is. It's just a way to create a virtual model of something, often engineering related, before you build it physically. And so it has some benefits in that you can see if you have like intersections before you put it into work, and you have the ability to create like laser cut or 3D printed pieces from it. And so it's really handy in robotics as well as in the industry to give some more experience and kind of plan ahead for your plans. And so there's quite a few different software platforms that you can use. The 4 that I've highlighted here are kind of the 4 most common in FRC or FTC and FRC. But I guess I can go over all of them, and then I can explain why I choose Fusion 360. And then for those who don't have it yet, I can show you how to get set up if that's the platform you choose. So on the left is SolidWorks. I think this is the most common in the industry. I know a lot of professionals we've talked to, and especially mechanical engineering, use it. And it's known for its high performance and can do very large assemblies. But it has some drawbacks, like it's not cloud-based, so you can't share files with other people as easily, and it's not compatible with Macs. And then there's my favorite, Fusion 360. It's not so much used in industry, but it's used very widely by hobbyists. I know most YouTube videos I watch of like engineers or people doing 3D printing will use it. And a few of the neat features that it's all cloud-based, meaning that if you have a team of multiple people who all want to do 3D modeling, it's really easy to share models between them and have multiple people, kind of like how Google Docs would work. And then it also has some neat features in that it's all kind of in one package. So you can obviously do the models of the robot or whatever you're building, but then you also have options of how you machine it. So if you want to like laser cut or 3D print, it's got built into it ways to do that, as well as way to render. And then one of my big things I enjoy with it is it's Mac compatible. And then there's Onshape, which has gained popularity recently because of the pandemic. It's all web browser based, so there's no download you need. I think it suffers a little bit in performance that way, but it's still very widely used in robotics, and it sounds like it's being adapted by the industry as well. And then finally on the right side, Inventor. I don't know quite as much where this one stands. I know historically it's been pretty popular, but now the same company makes it as making Fusion 360, and it seems like most of it is kind of shifting towards them. So these are just a few of the options. I think these are the most common ones. I'll be doing Fusion 360 for this, but if you prefer a different platform or you want to experiment, a lot of the concepts that I'm teaching will hopefully translate between all of these. So for those who want to use Fusion 360 and haven't already, it's free for students. And Toya can paste a link in the chat of how you get signed up. I know oftentimes you'll need some confirmation that you're a student, but once you provide that, it has no cost to you through your education. And then it hopefully is self-explanatory how you get set up with that. But for this demo, I'm going to assume people don't have Fusion 360. So you're not expected me to follow along. You can just kind of watch what I'm doing and get set up after. So for the lesson, I just wanted to show kind of this prototype of something I built in like half an hour. And so it's supposed to replicate something you might build this season with some Go Build the components, a few motors, and then the ring that we'll be shooting with. So I can jump in now to Fusion 360. And you can see once again the ring there. And another neat thing with Autodesk is that it's not just based on the application, but people can actually view it from a web browser. So Toy, if you wanted to paste in that second link, this is if you wanted to view it without having the file downloaded, you aren't going to be able to edit it, but you can at least pan around and see what it is we'll be building. But before we jump into building, the first thing we'll want to do is find each of these components. So fortunately, you don't have to create every one of these from scratch. If it's a part that's found in FTC, chances are it'll be available online. So just a few places I go. For this, I'm going to be using GoBuilder. So if you go to their website, they have linked in just about every product they have a 3D model for it. So say I needed this channel, they have a linked step file. So I could be able to download that. And then similarly with Rev Robotics, if you find any component from them, they also have a model. And so basically what this download is, and they actually have a completed library, which is super handy. But what this is it'll allow you to build up a library of basically every FTC component you own. So I can show you this is what our teams looks like. We have everything from like motors to gears and wheels. And you can see we have folders within these for like every specific type of wheel. And none of this was handmade, at least none in this folder. And that's kind of the beauty of 3D modeling and stuff like robotics, is that so much of this stuff isn't involving building from scratch. It's instead just importing existing items. So I'm going to jump into how we build this. I'm going to go pretty quickly because like I was saying, I don't expect people to follow along with me. But just kind of get a sense of the workflow, and I'll be highlighting some things that maybe wouldn't be so obvious to people who don't do robotics. Because like I was saying, one of the big things in robotics is how often you're inserting and combining components compared to what a lot of people are doing, which is building pieces from scratch. And so with this, there's nothing to build from scratch. It's all going to be just inserted components. So I'll start with a new design. And obviously, first thing I want to do is save this. I'll name it demo. And then in this project, I just have a few components I quickly downloaded. And so I'll begin to insert some of them. The first one will be this railing. So I can insert it by right-clicking and say insert into the design. And so now I've got the component loaded inside my existing design, and I'm able to modify it by spinning it or moving it along one or more axes. And then I'm satisfied with where that is. I can just hit OK. And now I have the first component. So then the next thing I'm going to do is begin assembling a few different components. So I'm going to bring in a motor. And once again, you can move it around, and this is not going to modify the actual file. It's just placing it into your existing design with a link to that assembly. Cool. So now I've got the two components that I need. I've got the channel and then a motor. And now comes where you have to align it. And so I'll first demonstrate what you don't want to do, which is you don't want to select the component, which you can do on this left side. and just say to move it. And this is what I used to do, and it's quite an awful way to do it. So just want to warn you ahead of time is you could technically just move every component roughly to the position you want it. And maybe you can get away with that, but you'll quickly run into issues with things being a fraction of an inch off. So not the preferred method. Rather, what you'd want to do is use what's called a joint command, which you can find in this top assembly. So in the assemble, you'll notice it has a joint among a few other features. And so when I click on that, now it's going to allow me to position these objects relative to each other. So the first one is going to be the one that I'm planning on moving, which is this piece. So I'll select that. And then I'll select where I want to move it to, which will be this channel. And then you'll notice that the component moves. Because of how this is set up, there's kind of this wonky thing on the side. But once I hit OK, it's going to assemble that in place. Cool. Is everyone with me so far? Cool. So now that I've got this in place, I guess the next step would be a hub, which I once again have in the file. So once again, I can right click that and say insert into the design. And then it pops into the origin. And then I can once again go into the joint and I'll select my first position. And for those who are confused where I'm trying to select, I'm basically trying to get 2 points that are going to be coincident to each other. So in this case, I want it to be the center of this piece. So if you can see that, it's the very middle of where the kind of cylinder is. And then the second piece I'm going to choose is going to be this motor shaft. And for now, I'm not going to actually place it where I eventually hope it's going to be. It's going to be kind of up higher. But from this now, what I can do is I can actually move it. So it's assembled into this position and I can move it some set distance. And so what I'm going to do is move it so it's just above where that is with enough space so that it's not touching. Cool. So now I've got a almost completed motor with a hub attached and all is quite aligned. So then the last piece to the side will be the wheel, which once again I have in my folder. So I can insert it. Okay. And then once again, I can create that joint. So I'll move it from that to this piece. And I think I'm going to place it along this. So as you can see, that looks about right. When I hit OK, it's going to move the entire assembly. And then I've got 1/2 of this wheel. Cool. So then I happen to know where the other motor will go, but I'm going to pretend like I haven't done this before. So I can bring up the ring. This is the official CAT model of the ring that they use in FTC this season. And I'm going to be able to do some inspections of it. So I can go into inspect and say measure. And then I can select, say, this line. And this will tell me the diameter of the ring as well as just some other info that may be relevant. But the diameter is the thing I really want to know. So it's 127 millimeters, or I'm guessing most of you work in inches. So I can switch that to inches. And it's 5 inches. So within the file that I have up, what I'm going to do is just kind of sketch out where I hope the ring will go. And then from that, I can find the optimal spacing along these. So I'll create a sketch. And this part is going to look a little complicated, but I'll link a bunch of resources in the chat of how you go about modeling this. But basically, I'm just going to find where the edge of this wheel is. And then I'm going to create kind of a 2D view of what a ring would look like. So we had said it's 5 inches. And now if I wanted to just be approximate, I could actually just drag this to where it is approximately going to be located. And then I can figure out the diameter of this again, which is 72. And then I'll make a second circle at 72. And so now when I align this, you'll notice it's going to be the center of it is going to be right next to this last hole, which is intentional. That's why I chose this component. And that's going to provide some cushion along the ring as well. So I'm thinking that's the hole I'm going to use. And once again, you can see all this is being very approximate because this isn't going to be where I'm actually putting the motor. This is just giving me a rough estimate of which of these holes I'm going to use. So I'm just going to copy this exact same process again, going on the other side, with inserting a motor and then the hub. And I'll go pretty quickly through this since you've seen it all already. And I'm just going to hide this sketch. That piece. Hub. And to answer your question, Emma, the game elements I'll link at the end, but they're all provided on the Andy Mark website. So if you go to Andy Mark, they have a full field model as well as models of individual components, which is super handy. You can find them down in the CAD files. And so from this, it gives you all the models, and it's really convenient to be able to measure like exactly the height of each of them.
We also have a question about how about all the nuts and bolts?
Oh, the nuts and bolts. Oh boy, yeah. So in an ideal world, you would insert all the nuts and bolts, and you can find them oftentimes either on their website or just loose models you can find on the internet. Generally for FTC, I'm not going to model those because just the time it takes to do so. But I know in FRC, we have some larger bolts, and so sometimes we can have issues with them, in which case we do often model those. But the modeling of them would be exactly the same as what I'm doing now. You'd basically be inserting components and then choosing points to move them to. Awesome. Well, with that, oops, I just realized that this wheel isn't in place. And try this again. Awesome, that looks about right. So then the last step I can do is actually insert the ring. And I know this is going to contradict what I had said just a little bit ago with not positioning them by dragging. But in this case, it's fine because the issue with dragging is not that it's inaccurate for the one component. It's that if you're modeling one component approximately and then moving another one on top of it, that's when you begin to run into all the issues of components not quite lining up. But in this case, all the ring's doing is having kind of a visual to show kind of where it is in relation to everything else. So it's okay to move it just approximately with these move tools. So I'll just position it like that. And you'll notice this is pretty close to what I had on this guy. Do we have any questions so far? I know I'm going really fast through all this. Unfortunately, you can't learn Fusion in an hour. So my hope with this is just you gather some more critical things, like especially joining components is one thing that isn't taught so much in the lessons, but for stuff like robotics is really vital to be able to know how to do. Oh, thanks for reminding me, Roach. Yes, you can. Yeah, so we had linked this into the chat, and for this model, if you want to see the same one, I can go to the web browser version, which I selected just by clicking on the little kind of globe with the eye in Fusion. And then this is my library in a web browser. And once again, I could send a link if anyone wants to view it. But this is the same one I had shown before. Well, if there's no other questions, then I can move into kind of a more fun part of this, which is the rendering. So like I said, Fusion, one of the great things about it is it's not just building a model, but it's also having all these features like doing animations and even like simulations to figure out where the stresses are on the components. But for this, I'm going to do a rendering, which is really handy, especially for documentation, where what I can do is I can go into the rendering environment. And once again, I'll go pretty quick because there's a lot of tutorials if you want to go more in depth. But basically, I can set the appearance of some of these things, like the ring already has some appearance set. But for these other ones, I'll just choose some coloring. And then I can go into actually rendering it. And just from experience, I know that it's kind of dim when it's set by itself, so I'll turn it up some. And then Fusion has this awesome feature that's free for students where you can have it rendered not on your computer locally, but on the cloud. And so what this will do is I can select cloud rendering and then the style. And it gives you kind of unlimited credit, so you can do as much as you want within some reason. But I've got the kind of view I want of this. I can pan my screen around and then I'll select render. And it says it's going to take about 20 minutes, which may be longer than this class is. But if you want to see what the renderings look like, I had showed them in this. So they have this kind of photorealistic appearance. And if you were to play around with it more, you could get it to look even more realistic. Got just a brief overview. Before we move on, did anyone have questions about any of this, or especially like joining components, because that's one of the real essential pieces of this?
Well, we have a question asking whether the cloud rendering is faster than the local one.
Yeah, so I think it's tough when I can actually go in and show a local one. So there's this kind of really quick one you can do, which is in Canvas, and you can actually watch it live as it updates. So you'll notice it begins really choppy and then it quickly begins to refine until it gets a pretty good look. For an assembly like this, that's super simple to build. It's debatable whether local is better. But I can tell you for having like a full robot model, it would take an hour or two on my computer, whereas it's 10 minutes in queue and then a minute to actually render on the Fusion side. And then if you did want to do a local render, it would just be selecting that one option. But yeah, good question. Was there any other questions before we moved on? No, cool. Well, I guess then what I can do is I can just quickly show what some other teams have done with renderings. I've downloaded through the years a bunch of different teams models as well as my own teams. So I can bring up a few of those. And I apologize if it takes a minute to load. Yes, I can. I think, let's see if it'll load. My computer's frozen right now. Maybe while that's loading, I can actually navigate from within the web version to grab the link of that. Yes, if anyone wanted to look with this alongside me, I'm just gonna post that link in the chat. And then hopefully it's loaded on my end. Yeah, there we go. So you can see it's just incredible amount of detail in some of these models. This was one submitted to a Catathon, which is, as the name might imply, a competition for catting. And so, yeah, you can just see the amount of detail that goes into some of these. And you'll notice with this one, most of these components are going to be custom made. Aside from like the wheels and motors, basically all of these plates were made from scratch, which I think for newer teams isn't quite as relevant, but for those who are more advanced, you're looking to get into some more kind of high-tech development strategies. This is a great way to do so. And unfortunately, some of the detail doesn't save. Like I'm sure on the actual model, this was animated, so you could actually pull the slide and it would slide along. But because of how it transfers between applications, that doesn't always work out. And then maybe relevant to this season, I can bring up a kind of fancy intake somebody had modeled from previous. Once again, I can try to find the web version of that. If anyone wants to look at this with me, here is the intake model. And another neat thing about these is if you find a model that you really enjoy, like I know my team's been looking at modeling somewhat after this robot, you can download the files from the links that I've provided and then be able to inspect them more closely. Especially one thing you'll want to look at is how they arrange their file structures. You'll notice it's not just every component laid out in the browser, but instead you have these kind of hierarchies of a drivetrain and then like every component that's involved in the drivetrain. And sometimes it goes even deeper, like you'll notice the mechanism wheel has components within it, and then each of these components have components. So it's definitely, if you're going to build an entire body, you want to have a hierarchy system. So just what I was saying is another design. This one is once again almost completely custom made, but this gives you kind of an appreciation of what you can do within Fusion. Yeah. And then I can quickly demo a few of the bots that my team has made. One thing that my team has found is towards the end of the year, our bot designs, at least the models of them get kind of less defined and yeah, kind of better. Hopefully this one is still working. I'm gonna guess this will take another minute to load. Does anyone else have questions while we wait?
I had a question about when you're uploading these things to the cloud. I think I tried to do that once accidentally when I was practicing with it, and it asked me to if I wanted to use tokens or something.
Oh, I think I know what you mean. So uploading the cloud, it does all automatically, and that it's cloud-based. So whenever I make even just a modification to a design, it's going to save it in the cloud for anyone to access. I'm guessing what you're thinking of is the rendering, which I can jump back to once my computer stops loading. But yeah, in that case, it does have this token system, which if you're using this as a plate, as kind of paid software, you'd have to pay to get tokens, then you spend them to have these things rendered. But being students, that's all free. So as long as it's under 20 tokens, which is basically like less than a 4K image, you can do it for no cost. But here we go. This is my bot design from my team's bot design from last season. So you can see it's not quite as detailed as like the other teams. We didn't bother to do stuff like put screws in every hole. But we did use a good combination of both custom built components like these side panels that we designed ourselves, as well as components that were already in place, such as these motors and pulleys and such. Yeah. Oh, and then I guess I can jump into demo that rendering again. And with any luck, this one will actually have finished rendering. Unfortunately, it's still on 2, but if I do a new rendering, I'm guessing this is what you're looking at, and that it says it has a credit requirement, but that's not necessary if you have the education license. Good question, Jacob. Yeah, so I haven't used the exploded view a ton, but I can tell you it is pretty difficult. I believe I used it a few years ago. It's difficult if you're trying to like assemble it, but for something like it, it's great for like an engineering notebook. So to show what Jacob's describing, let's see if I can get back to it. It's been a while since I've tried this, but there's this awesome feature where you can have an exploded view. I believe just like that. Let's see. But so basically, for those who haven't tried this yet, you've likely seen it in like IKEA furniture is what comes to mind for me, in that you have kind of the assembly, but all the components just spread out along some axis to show you kind of how they all come together. And like Jacob was kind of saying, it is difficult to see what all these components are when you have a bod with 20, 30 or more components. But for something like an engineering notebook, it's a great visual to show just kind of like how these assemblies come together and what all is shown in the robot. So I'm gonna guess this is gonna take a while to load, just because it has to move all those components. So maybe I'll set that aside. Oh, but for Roach's question, so I've got a Mac. It's a higher end Mac, the MacBook Pro. But I think Fusion has been good on just about all computers. I think if you have like a Chromebook that's very limited in power, it's going to have some issues. But I know like Troy has used it on a MacBook Air and it's worked pretty good. And I think, yeah.
Yeah, I put it on low display detail as well for really big components, so it's not displaying super high detail.
Yeah. Yeah, and I think that's one of the benefits of Fusion 360 and Onshape over, say, like Inventor or SolidWorks, just because those are so high performance, is going to take a lot more loading power. Maybe that loads. I can jump into the last section of the presentation, which is just some resources that are available for people of all skill levels to learn more about Fusion 360. So those were just pasted in the chat. The top one is actually an official tutorial of how you use Fusion 360 in FIRST Robotics. It's kind of both FTC and FRC, but this is going to go more in depth on a lot of things that I covered, along with just kind of more simple designs. But like I said, it's kind of emerged between FTC and FRC bots, but it is really great for learning a lot of the basics. And then if you really want to start from the ground up, there's a bunch of great tutorials from Autodesk, which have all lessons. So like this is if you wanted to begin with basically no knowledge of Fusion and learning all the little details of how you do 2D sketches and build custom components, all the way up to doing these big assemblies like we have now. And so the one I linked is actually just one module and a huge library of modules that Fusion 360 has on just about every aspect of the software. And then there's also a lot of great YouTube videos. I know the guy that I watch most often, his name is Lars Christensen, and he does Fusion 360 quite often. He's more
Fusion 360 is very
more advanced in his workflows, but if you have some like specific thing you're looking to solve, like I know one thing that my team was looking at is the difference between bodies and components. And so for that, he has thousands of videos detailing all these different little aspects of Fusion 360. And then finally, like I was talking about, is part libraries. So instead of building each of these components from scratch, take advantage of the manufacturers having them all available. So Rev has a great one in that it's one file, which is going to download immediately, that has just about every component Rev has made. And then like I had linked before, we have the Andy Mark one where you can download sections or the entire playing field. I'll link below. And then if your team uses something like Tetrix or GoBuilder, you can download those components just by going to the website and selecting them and then finding where you can download the step file. And yes, George, all of these packages work for any software that you use. Oh, and I guess maybe one last thing I should do, because I neglected to do this at the beginning, is, I might have crashed Fusion. Shoot, I guess I won't show it then, but to upload a file is pretty simple. You just click the upload tab in the top left and then drag the file in.
Well, we have multiple questions now.
Yeah.
The first one is about whether it's worth it to make a virtual robotics lab.
Virtual. I think if you mean like the library of all the components, definitely. I know my team, beginning freshman year, we basically scoured all over Tetris's website and downloaded every component we could find and then began grouping them together. I know in FRC it was more gradual in that if we had some component, we'd go to the websites and download just the files we needed. But I think, yeah, having a large library and especially having it organized so that it's easy to find the components you need. Because I think over half the time you're spending in modeling is going to be dragging these components in and getting them aligned with the robot.
Yeah, and the second question is whether there's a file in Fusion that allows you to run your robot on the field.
There is, yeah. So I haven't used it, but it's this awesome software called Synthesis, Autodesk Synthesis, which I believe is more oriented towards FRC, but it has FTC aspects as well. And I know there's also some teams who had developed different software, just like third-party software that you could drag a robot into and have it run. I haven't used either of these programs yet, but I know of quite a few teams who do and have had great success, like training drivers or even uploading code to them to see if their autonomous works as they hope. And I can link this in the chat if anyone wants to learn more about it. Did we have any other questions? It's not, unfortunately, Ardian. So Ardian's question is Synthesis available on Mac? And it isn't, as far as I know. I know I tried to download it on my computer and it wouldn't run. So yeah, unfortunately not. Do you want to elaborate on your question, Roach? Oh, I see. Yeah, so I know maybe if Roach, you want to talk more about this, Onshape is one that I've just briefly looked at. But it has the benefit of being all web-based so that teams don't have to download software, have a bunch of computations running on their computers.
Yeah, I could do a brief, quick plug for that. We went into online learning for our engineering classes, and we had students that had Chromebooks and didn't have access to PCs or Macs. We used Onshape, which was bought by a PTC company that makes Creo, and was developed by SolidWorks employees that kind of wanted their own thing. And it's completely web-based, so you don't have to download and install anything. You just need a Chrome, browser essentially to run it in, and you can do all the same things as far as like sharing parts and setting up a team. So for my freshman team, that's what they're using. It's not quite as advanced as Fusion 360 in terms of all the capabilities, because it's newer and being developed. But for most of the basic stuff that you need to start a rookie team out doing CAD, it's fine. So a little bit difficult to get the 3D printers or to get the laser cutters, but just for modeling parts, I would say that's a good way to go for a team that has limited tech or limited CAD experience.
It looks like Allison says that the FTC YouTube channel also has Onshape tutorials. Yeah. Any other questions before we go? Unfortunately, not, Ardian. I think if you want to learn about it, there's a lot of great resources online. Like Allison was saying with the YouTube videos. And I'm guessing Onshape has their own tutorials like Fusion has. So yeah, definitely check those out if you're interested in Onshape. Awesome. Well, if there's no other questions, I guess the last thing is I'll just pull some plugs for upcoming workshops. So next week we've got building and maintaining team websites. And then the following week we've got outreach and then film and video. So if you're interested in any of those topics, be sure to tune in. And with that, thank you all for coming. I'll see you next week. See y'all.